If it feels like you're hearing about heat pumps absolutely everywhere here at the start of 2026, well, you're not wrong. This technology has suddenly jumped right to the center of a huge conversation about how we're all going to heat our homes in the future.
It really does seem like it came out of nowhere, doesn't it? One minute you'd barely heard of them, and the next, they're a massive story in the news, they're a key policy for governments, and heck, maybe your neighbors are even chatting about getting one installed.
And with all that attention comes a whole lot of noise. For every single person telling you they're the future, you've got a skeptic on the other side claiming it's all just, hot air. There is a ton of hype, for sure, but there's also a lot of confusion.
But make no mistake, this isn't just talk. This number right here, 450,000, that's the UK government's official target for how many heat pumps they want to see installed every single year by 2030. To give you some perspective, that's more than double the number of new homes built in the UK in a good year. It's a huge, huge ambition. And it just goes to show how serious this push has become.
Okay, so let's dive right in. Our goal today is to cut through all of that noise. We're going to figure out what's real, what's a myth, and get to the bottom of why everyone, and I mean everyone, is talking about heat pumps right now.
Right. First things first. What on earth is a heat pump? Honestly, the simplest way to get your head around it is to think of a refrigerator, but just running in reverse. Instead of pumping heat out of a box to keep your food cool, it pumps heat into your house to keep you warm.
And the really crucial word there is moves. See, your traditional boiler has to burn fuel to create heat from scratch. A heat pump doesn't do that. It just moves existing heat from the outside air into your home. And that simple difference is the secret to its mind-blowing efficiency.
So how does it do that? Well, it's this really clever 5-step cycle. It all starts with a special refrigerant liquid that can absorb heat from the outside air, and yes, even when it's freezing cold, and it turns into a gas. Then a compressor, which is what uses most of the electricity, squeezes that gas, which makes it get really, really hot. The super hot gas then flows inside your house, releases all that lovely heat into your radiators, and as it cools down, it turns back into a liquid, ready to go outside and start the whole process over again. It's just a beautiful, simple, continuous loop.
Now, you'll generally hear about two main types. The most common ones are air source heat pumps. They look a bit like an aircon unit, and as the name suggests, they pull heat right out of the air. Then you have ground source pumps. They're a bit more involved, using pipes buried in your garden where the temperature is more stable. They're even more efficient, but yeah, you do need a bit of outdoor space for those.
All right, so now that we've got the basics down on how they work, let's get to the fun part. Let's tackle the biggest criticisms you hear head on. This is where we separate the real facts from the fiction.
This is it. This is probably the #1 question on everyone's mind, especially in a place like the UK. It just seems wrong, doesn't it? How can you possibly pull heat out of freezing cold air? Well, the science is pretty cool. Even when it's 0 degrees or way below, there is still a surprising amount of heat energy in the air. We measure a heat pump's efficiency with something called a coefficient of performance, or COP. A COP of 2 just means for every 1 unit of electricity you put in, you get 2 units of heat out. Now look at this chart. Even when the temperature drops to -10 or -15 Celsius, the efficiency consistently stays way above 2. This isn't theory. This is real-world proof from thousands of systems. And we've got fantastic data from right here in the UK that backs this up. A huge study by the Energy Systems Catapult found that even on the absolute coldest days, when it hit -6 degrees, the heat pumps they were testing were still running at over 240% efficiency. So the science and the data are crystal clear. Yes, they absolutely work in the cold.
Okay, on to the next big hurdle, the running costs. We all know electricity costs more per unit than gas, right? So doesn't that mean my bills are just going to shoot through the roof?
Well, this brings us right back to that efficiency game. Your brand new, top-of-the-line gas boiler is at best about 90% efficient. You put 1 unit of gas in, you get a little less than 1 unit of heat out. But a heat pump, like we've seen, is somewhere between 250 to 400% efficient. It gives you 2.5 to 4 units of heat for every single unit of electricity it uses. So even if electricity is a bit pricier, you just need so much less of it. With smart energy tariffs, they can absolutely be cheaper to run than a gas boiler.
This is a big one, especially in the UK with all our older, sometimes drafty housing. The common wisdom is that you need some kind of futuristic, perfectly sealed house for a heat pump to even work. But you know what? The real-world data tells a completely different story. That same massive 2-year project was designed specifically to test this idea. They put heat pumps in all sorts of homes, Victorian terraces, 1960s flats, you name it.
And their conclusion was totally unambiguous. They couldn't find a single property type or age that was unsuitable. Now, better insulation always helps any heating system, but you do not need a perfect home to get the benefits.
And finally, the lifestyle question. These things have a fan unit outside. Is it going to create this constant, annoying drone in my garden all winter long?
A modern, well-installed heat pump is actually surprisingly quiet. We're talking about a noise level between 40 and 60 decibels. To put that into perspective for you, that's pretty much the same background hum as your fridge or a modern dishwasher. It's really not the disruptive racket that some people fear.
So the technology we have today is already fantastic. But what's really, really exciting is where it's all headed. The heat pumps being put in today, in 2026, are part of a much smarter, more connected home energy system.
We're seeing 4 major trends taking off. First, you've got AI and smart automation, so the system actually learns your family's routine and checks the weather forecast to run in the cheapest, most efficient way. Second, they're getting integrated with solar panels and home batteries, so you can literally heat your home with free energy you've generated yourself. Third, a whole new generation of eco-friendly refrigerants with almost zero environmental impact are becoming standard. And finally, you've got these incredible cold climate models specifically built to work perfectly in deep freezing conditions, well below -20 Celsius.
Okay, let's pull all of this together. Why the sudden explosion of interest? Why are we all talking about this now?
At its core, the whole argument really boils down to this one simple, stark comparison. On one side, you've got the best gas boiler money can buy, which, because it's burning something, will always be less than 100% efficient. And on the other, you have a technology that is routinely 300% efficient, sometimes even more. It's just a fundamentally different and better way to make things warm.
And what's really happened is that the technology has finally hit maturity at the exact same moment that governments are getting deadly serious about their climate goals. So the rage right now, it's the perfect storm of proven technology meeting powerful financial incentives. With grants of up to £7,500 in the UK and rebates up to $8,000 in the US, the biggest remaining hurdle, that high upfront cost, is being directly tackled.
So you see, this isn't just about swapping one boring box on the wall for another. This is about a fundamental shift in how we think about energy in our homes. The final question isn't just, do heat pumps work, because the evidence is clear that they do. The real question is whether this technology is about to become the new, intelligent heart of the smart, green homes of our future. Thanks for joining us on The Explainer.